To solve an equation with variables on both sides, use inverse operations to collect variable terms on one side of the equation. Equations are often easier to solve when the variable has a positive coefficient. Keep this in mind when deciding on which side to collect the variable terms. In our first two examples, we are looking at equations that have variables on both sides of them. So in example 1, we have 4b plus 2 equals 2b plus 14. The goal is to collect the variables on one side and the coefficients on the other, or the constants. For this problem, I'll start by subtracting 2b from both sides. I'm left with 2b plus 2 equals 14, because the b's on the right cancel out. Now I'm going to move the constant of 2 by subtracting it. So I subtract 2 from both sides. I've got 2b equals 12. Now I have my variables on the left and my constant on the right. The only thing I have left to do is get rid of the coefficient of 2, and since I'm multiplying by 2, I'll divide by 2 to undo it. And so my final answer for this problem is b equals 6. In example 2, I'm doing something very similar. I have 7n minus 2 equals 5n plus 6. I want to gather the n's on one side and the constants on the other. So I'm going to subtract 5n to start the problem from both sides. I'm left with 2n minus 2 equals 6. Now I'm going to add 2 to both sides of the equation. And I'm left with 2n equals 8. The last thing I need to do is undo the 2 with the n. And in order to do that, I'm going to divide by 2. And you get n to equal 4. Go ahead and try the third example on your own. Pause the video, and when you're done, press play and check your answers accordingly. In example 3, I started off by subtracting 0.3y from both sides. I ended up with 0.5 equals 0.4y minus 0.3. I then added 0.3 to both sides, resulting in 0.8 equals 0.4y. Then I divided both sides by 0.4, and I got an answer of y equals 2. To solve more complicated equations, you may need to first simplify by using the distributive property or combining like terms. In this example, we are given 2 times the quantity 5x minus 1 equals 3 times the quantity x plus 11. So the first thing I want to do is I'm going to distribute the 2 throughout the quantity on the left and the 3 throughout the quantity on the right. This gives me 10x minus 2 equals 3x plus 33. The next step would be to get the variables on one side and the constants on the other. So I'm going to subtract 3x from both sides. That gives me 7x minus 2 equals 33. I'm now going to add 2 to both sides. And I've got 7x equals 35. I need to divide both sides by 7, and I get x to equal 5. Go ahead and try example 2 on your own. Pause the video, and then when you're ready, press play to see the answer. In example 2, you have to distribute the 2 on the right side of the equation, but at the same time, you have to make sure that you're combining the like terms of 15 and minus 9 or negative 9 on the left before you can start solving for x. So what you should end up with is 3x plus 6 equals 2x plus 4. Then you can start solving for x by subtracting 2x from both sides, followed by subtracting 6 from both sides, which results in x equaling negative 2. All right, example 4, very similar. We're going to have to simplify or combine like terms on the left side of the equation with the minus 6 and the positive 4a, the minus 6a and the positive 4a. And on the right side of the equation, we're going to have to distribute the negative 5 throughout. So let's go ahead and simplify that down. we get 7 minus 2a equals negative 1 minus 40 plus 10a. The next thing we need to do is combine the negative 1 and the negative 40 on the right. So now I have 7 minus 2a equals negative 41 plus 10a. Now I can start solving for a. I'm going to add 2a to both sides. So I have 7 equals negative 41 plus 12a. Then I'll add 41 to both sides. And this gives me 48 equals 12a. The next step would be to divide by 12. And we should get a to equal 4. So an identity is an equation that is true for all values of the variable. An equation that has an identity has infinitely many solutions. Some equations are always false. These equations have no solutions. So this is an example of infinitely many solutions or no solutions. So we have to determine which that is. So let's go ahead and solve this first example. The first thing we need to do is combine like terms where necessary. So 10 and positive 1, and then 7x and negative 12x. So on the left, this simplifies down to 11 minus 5x. On the right, we get negative 5x plus 11. The first thing I'm going to do is go ahead and add 5x to both sides. And upon doing so, I should notice something very special. The x's in both cases cancel out, and I'm left with 11 equals 11. This is a true statement. There are no variables. We don't have a value for x anymore in our equation, but this is still a true statement. And since this is a true statement, this tells me that it's an identity, meaning that no matter what value of my variable I choose, it's going to work. This has infinitely many solutions. Let's look at example 2. 12x minus 3 plus x equals 5x minus 4 plus 8x. Same idea. Let's collect like terms. So on the left, we've got 13x minus 3 equals 13x minus 4. Let's start by subtracting 13x from both sides. Cancels, cancels, just like the last problem. But this time I've got negative 3 equals negative 4. That's not a true statement. They're not really equal. So this is a false statement, so it has no solution. No matter what value we choose for x, this is not going to work. So this is an equation with no solution. All right, a word problem. 4 times Greg's age decreased by 3 is equal to 3 times Greg's age increased by 7. How old is Greg? So let's just look at the first part of this. 4 times Greg's age decreased by 3. Well, let's let x be Greg's age. So that means we've got 4 times x minus 3. All right, and we know that's equal to the other sentence or the other piece of the statement. 3 times Greg's age increased by 7. So 3x plus 7. So now that we have our equation set up, all we have to do is solve. So I'll start by subtracting 3x from both sides. I've got x minus 3 equals 7. Add 3 to both sides. And you're going to get x equals 10. So that means Greg is 10 years old. Go ahead and try this one on your own. Pause the video. When you're ready to see the answer and talk about the solution, press play, and it should be there. So you have to create two statements in order to create this equation. Your first statement or your first expression is 60 plus 44H, meaning that John planted 60 bulbs and plants 44 bulbs per hour. Where Sarah, on the other hand, or the other expression would be 96 plus the 32 bulbs per hour. And they're looking to see when they will have planted the same number. So they're setting them equal. Anytime you're looking to know when two quantities are going to be the same, you're generally comparing them by setting them equal to one another. And so now we have one large equation. So we can go ahead and solve this. We'll subtract 32, h from both sides. Then we'll subtract 60 from both sides. And we get 12h equals 36. We'll divide by 12. And we get that after 3 hours, they will have planted the same amount. The last part of the question says how many bulbs. So we need to know how many bulbs that would be. So the easiest way to figure this out is to plug it into one part of the equation. So take one of the expressions, like 60 plus 44h, and we're going to plug this in for h. So that becomes 60 plus 44 times 3. And when we evaluate that, we get 60 plus 132, which gives a total number of bulbs as 192. So the total bulbs planted in 3 hours would be 192.